squares. This is one of our special patterns in factoring. What we have are always going to be two terms. You know, here's, oh, we don't want that pen, do we? There's two terms. We also have, you know, two terms over here. If you notice, they are separated by subtraction. That's what makes it the difference. Now, what is it that's going to make it squares? What we want to ask ourselves is, do we have perfect square numbers that we're working with? You know, in front of the x squared is x times x, but it's also a 1, and 1 is a perfect square number. The 81 is a perfect square because it's 9 times 9. So the way that this factors, every single time, if you have a difference of squares, you know, the difference of these two squares, we're going to factor the x's go here, the 9's go in the second spot, and we get a plus, and we get a minus. And that is how we do a difference of squares. If we were to FOIL this out and check it, it would work out. We'd have a negative 9x and positive 9x. That would cancel, which is why we don't have a middle term with just the x in there. So this next one, 25x squared. 25 is a perfect square number, and x squared is x times x. So this is really a 5x times 5x. This is what gives us the 25x squared. 36 is a perfect square. That's 6 times 6. So when we factor this, the 5x's go in the first spot, and then the 6's go in the second spot, and then it's just a plus in one spot and a minus in the other. And that's factoring a difference of squares. We want to make sure we can recognize the pattern first, and then it will factor this way every time.